Hey, we're going to do a ray diagram for a diverging lens. So kind of set things up a little bit here. I've drawn my principal axis, and I'm just going to highlight the other features that we need to draw this ray diagram. We need to identify the focal points. Now, for a diverging lens, if you'll recall, parallel rays of light will hit a diverging lens, and they will diverge away from a virtual focal point. So here's a focal point on one side, here's a focal point on the other side. Just like any lens, it'll have two focal points, but they're virtual. That's important when we draw these. For me, easiest one to get wrong in terms of ray diagrams is the diverging lens, because of the virtual focal point. Then we can identify a couple points, twice the focal point if we want over here. They don't really tell us a whole bunch in terms of using them to draw the ray diagram, but there are key points at which we can locate the object. So I'll identify them, but I won't use them as I do this ray diagram. All right, so ray number one, the usual. The first ray will go parallel to the principal axis, like this, and then it will refract. Now remember, it refracts away from the focal point. So it'll do something like this. If we were to trace it back, this ray would appear to be originating back here at this focal point. So I don't know if that's totally straight, but you get the kind of idea. I don't want to trace this one back. I want to use a dotted line, so I'll just do something like that. I can clean it up later and put some straight lines if you like, but I'm going to leave it like that. Bear with me. We'll see if it needs cleaning up later. All right, the second ray. That's the ray that goes, let's do this. That's the ray that, this is the ray that you got to be really careful on. Virtual focal point. So avoid the temptation to put this ray through the focal point over here. If done properly, when it comes to virtual focal points, rays will never really go through that focal point. So we're going to draw a ray that heads towards this focal point. It's not going to get there because it's going to refract parallel to the principal axis. So that's the second ray. And again, you can see how this one, when we're done, these things are not going to run into each other. We're probably going to have to trace these back to see where they originate, and it's somewhere back in here. So again, I'm getting a little sloppy. In the case of when you have a ruler and stuff, you can do this a lot neater than I'm doing it, but this will give us a pretty good idea qualitatively. Finally, if we wanted another ray, not that we necessarily need one here, but if we were to draw a third ray just to confirm everything that we've been doing so far, it would be this ray that goes through the geometric center of the lens and is basically unaltered. And so if we trace this one back, I just want to make sure you understand that this is happening. This one traced back would be on top of itself right here. And lo and behold, all three of these rays end up at the same spot. So as usual, that will tell us where the tip of our image is being produced. And then we draw a vertical line connecting that point with the principal axis. And there's my image. So in terms of image characteristics, we have a image that is not real. It's a virtual image. Well, let's start. How do we usually do this? So yeah, it is smaller. So I keep my consistent characteristics. So size-wise, it's smaller. In terms of its attitude, it is erect. And it is a virtual image because we had to find out where the image is being produced by tracing back these virtual rays. And those virtual rays, remember, are traces back of the refracted rays, not the incident ones. We trace back the refracted rays, and they all end up producing an image back here. So going through these fairly quickly now, but if you're following along in order, you started with concave and convex mirrors. Then you probably did a converging lens. Now we're doing diverging lens. And the idea is this: we are really trying to just get a sense, not a no definition of each of these lenses or each of these rays. We really want to have kind of a feel for each of them, do them between the lenses and mirrors, that We don't have to memorize some textbook instruction on how to draw it. We just have a sense that, we always draw rays. I mean, think about it. You can always draw a ray that goes parallel to the principal axis, and then it either reflects or it refracts, and it might reflect or refract through the focal point, or it might be away from the focal point. But that ray is kind of consistent in that sense. We always have a ray like this one that we've drawn here that either goes through a real focal point or towards a virtual focal point. It's going to reflect or it's going to refract, depending on if it's a mirror lens, and it's going to go parallel to the principal axis after that. And then we're going to have one of our rays that basically is a straight line, hits our optical device, and either goes through like it does for a lens, or it bounces straight back like it does for mirrors. So again, I really would discourage anybody that thinks they got to memorize, 3 rays for 4 different devices. It is 3 rays. You just tweak them a little bit for each device. And if you can do that, then you're gold.